Greetings, welcome to this tutorial. The purpose of this will be to show you how you can use StatCrunch to help you with your current homework assignment, and specifically for anybody who's not taking my class right now, if you run across this video, this is how to use the website StatCrunch to get some two-population or paired t-tests completed. So this example is going to start with this setup. We have two different sleeping drugs, drug 1 and drug 2, and we have 10 participants, and we are tracking how much sleep they gain or lose when taking the different sleep aids. So for example, person 2, they lost 1.6 hours of sleep on average when taking drug 1, but they gained 0.8 hours of sleep while on drug 2. And if we treat this as paired data, which the original data set was, then this is 10 individuals, each with two measurements, once with drug 1, once with drug 2, and we can assume these comparisons are made from a baseline set before the study. So track them for a week, see what their average sleep amount is per night, and then track them for a week on each of the two different drugs. So let's see how we can do this in StatCrunch. So I've got the StatCrunch window open here from the home screen, from the My StatCrunch. Let's go to the Open StatCrunch. This will give you a blank sheet to work with, and we can start by typing in some of the data. So for var1, I'm just going to backspace, get rid of that, and I have drug 1, down arrow, and start putting in the values. So I've got 0.7 hours of sleep, lost 1.6, lost 0.2, lost 1.2, lost 1, gained 3.4, gained 3.7, gained 0.8, gained nothing, same as the original, and gained 2 hours. For drug 2, we have what appears to be a much better drug, just in that more people are gaining hours of sleep, assuming that's what we're looking for. But we will do a few tests to verify. Alright, so we've got the two different columns placed, and if you're thinking about doing this with homework 4, these would be the weights of the fish in 1995 for drug 1 perhaps, and weights of the fish in 1996 for drug 2. Now we go from here, we can make some sample statistics just like we did in the earlier project, but let me start by showing you where to get the differences. So instead of having to do the differences completely by hand, we can ask StatCrunch to do them for us. And I realized I did that too quickly, so what you'll want to do is go to Data, Compute Expression, and this window will pop up for you. And here is a whole list of different functions that StatCrunch will evaluate for us. And I know I'm going to be looking for a difference, so y minus x. And I'm going to go ahead and say that drug 2 is going to be my y, and my x will be drug 1. So I want to take the difference of drug 2 minus drug 1. I've selected this equation. I want to set expression. You'll see it coming up here, and then compute. And a little window pops up telling us things have happened. Close that. And here's this third column that's been populated by StatCrunch for us, and it's labeled drug 2 minus drug 1. Helpful name, tells us exactly what's in this column, and I will leave that name as is, but you can always rename it by clicking in here, backspacing, give it a name that you would like. I would prefer to leave it this way for myself, just so that it's very easy for me to go right to the column header and remember, okay, I took drug 2 minus drug 1. Now the first thing I want to show you is the paired data tests. These can be done in two different ways. If you remember from lecture, I made it a point to say that when we have a paired data test, it is the same thing as a one population test for just the difference column. So first, let's just look at some of the summary statistics. I can get all three of them all at once, and I'm only concerned with a couple different parts. So I'll move this down. Sample size is good, the mean is good, the variance could be useful, standard deviation could be good. Standard error, this is the sample standard deviation divided by the square root of the sample size. Not the most useful to me for our purposes with this exercise, so I'll get rid of it. Same with the median range, some of these other non-parametric things that I don't really need. So I'm only going to get what I absolutely need, and highlighted those, calculate, and we're used to seeing this. Here is our sample statistics. Sample size is here, mean, variances, standard deviation. And if you notice, there is no easy relationship for the standard deviation. You have to deal with the variances in order to get these. And the difference here, remember when we're dealing with the difference, it's just this column. I don't care what the initial values were, all I care about is the difference. So make sure you're treating it appropriately. So now that I have these summary statistics, these are also things that will be generated by the different tests. I'm just going to minimize that window. Let's start with a paired test. Now, that difference column is not necessary to build immediately. And we can just go directly to a paired test. So stat t-test paired. And our first sample is drug 2, our second sample is drug 1. And I'm picking them in this order to stay with the convention of drug 2 minus drug 1. If I want to get those differences to use later, I can check this box. I'm going to go ahead and do that, and you'll see that in this column var 4 will be relabeled as differences, and we'll have the same values that we got in this column here. So for easy comparison, I'm just going to build a 95% confidence interval and calculate. And here's our paired t-test, 1 versus 2. Here's our sample difference, our standard error, degrees of freedom, which is appropriate. We have 10 samples, so n minus 1 is 9. And then our confidence interval. And since the interval is strictly positive, we can conclude that drug 2 is more effective for gaining sleep. People are gaining more sleep by using drug 2 than they did by using drug 1. Now let me show you how we can compare this to the one sample test. So if we go t-stat one sample with data, and I pick only the differences that we calculated. Again, if we look at the difference column here, it's the exact same thing. This is the one that came from the paired test that I stored just for an example. This is the one that we had StatCrunch do originally for us. So from here, I'm only concerned with this. Again, I'm doing a one sample t-test. Next, I'm actually going to do a confidence interval, 95%, so same level as the paired test. Calculate, and here is the one sample t-test. And I'm going to pull back up the paired test. Now, if we look at the results, sample means are the same, standard error is the same, degrees of freedom are the same, the lower and upper limits are the same. This is a one sample test based off just the differences. This is that paired test. So the advantage of using software is you don't necessarily have to build that vector of differences, but you can if you like. And we get the same result from a one sample test of just the differences, because that's what we're interested in, is that difference, not the initial values. Or we can just go directly to the paired test. If we want to do a hypothesis test, take your pick, just do the paired again. So I'm doing drug 2 versus drug 1. Not saving differences this time. I want to do a hypothesis test to see if drug 2 is better than drug 1. So the null difference should be 0. And I want to see if drug 2 is greater than drug 1. And calculate that. There we go. There's our null and alternatives. Very, very small p-value. I can conclude then that drug 2, we gain more sleep than drug 1. And perhaps we want to test to see if we gain at least an hour's worth of sleep. Which for a college student would be, in some cases, doubling sleep. So I want to see if drug 2 versus drug 1 exceeds 1. P-value is 8%, so testing at an alpha 5% level, I would have to fail to reject and say there's not enough evidence to say that we actually do gain at least 1 hour of sleep. That's not that disappointing, but not too bad. So this is how we want to do the paired tests. Let me next show you how to do the two sample tests. So stat t statistics 2 sample, and again these are all t tests because I have sample data. I don't have a sufficient sample size to use z stat, and I don't have any population information, only these observations, and I'm making the assumption that the amount of sleep or the difference in the amount of sleep that a person gets is a normal random variable. So I do the 2 sample with data. Sample 1 is drug 2, sample 1 is drug 1, and this is a very important thing. Remember, in our class we have decided that our default is to assume variances are not equal to each other. StatCrunch takes a different default. It's deciding to pool variances, which is assuming that the variances are for the 2 samples are actually equal to each other. So every time you do the 2 sample test, you will want to unselect this. You want to make sure that that checkbox has no check in it. That's very, very important. We'll get different results. I'll show you that in a moment. So we do the next. Let's just build a confidence interval. Next, calculate. Now notice we get a very different result here. If I have a 2 sample t-test for the difference between drug 1 and drug 2, I have a 95% confidence interval ranging from -0.2 to +3.3, whereas if I look at the paired test, or a paired confidence interval, the limits are from +0.7 to +2.4. So a very, very different interval. This one's considerably larger. I have a non-integer degrees of freedom. And if you think about what's going on, why does this happen? The reason for it is that when we deal with paired data, we have one experimental unit with multiple measurements, and we are eliminating that variance within each individual. I know the baseline for person 2 or 3 or 4. I don't have to worry about how a difference between person 3 and person 4 works because I know their baseline. I know what their difference is between the 2 drugs. Whereas when I'm doing the 2 sample test, which is this one here, this is referring more to having 20 people in the study. 10 of them taking drug 1, 10 of them taking drug 2. And now I've got a lot of variance added because of the differences in the individuals. And it's not surprising that I should have a larger standard error, which I do, and a much larger interval. And of course, it's a computer. It can deal with the non-integer degrees of freedom. If you were going to use a table to do this, you would want to round down to 17 degrees of freedom. Let me show you the difference between this and when we pool our data set. So if you forget to uncheck this box, I want to leave it checked. I want to again build a 95% confidence interval, calculate. Now notice I still get the same result in this particular case in that there's no significant difference. 0 is still in the interval. Here's the original one without the pooled variance, and StatCrunch very politely provides that information, which was pooled and which was not. So equal variance, unequal variance. Big difference. Degrees of freedom here are non-integer. Remember the big nasty looking equation for finding degrees of freedom? Non-integer. Whereas if we have equal variance, we can assume then that the degrees of freedom would be the sample size of sample 1 plus the sample size from sample 2 minus 2. So 20 minus 2 is 18. And we still have the same result, but a slightly narrower interval in this case, ever so slightly. So not a huge difference in this particular case. However, it could impact some other studies. So you want to make sure that our pooled variances or unpooled, and this is the default. Alright, if you have any questions, please send me an email or ask me in class, and hopefully this will help you with your homework. At the very least, it should be a way to double check your work, especially for the sample statistics where we need the sample size, the mean, and the standard deviation. You can also get the variance in there. That might help you when calculating the degrees of freedom later on. So again, there's that. You may find this very helpful for your current homework assignment. If you have any questions, please send me an email, and I will see you in class on Wednesday.